Hey guys, Mr. Ye here, and today we are going to be covering section 2.4 from our textbook, which is kind of a nice recap of some topics we've already talked about, and an exercise in just algebraic manipulation of equations, converting from different forms whilst not changing the actual equation. So we've already seen many different ways to write linear equations. We have our standard form, which we focused on back in 2.2. which was ax plus by equals c. And if you remember, that had all sorts of rules. We want our a to be positive, so we have positive x's. A, b, and c all have to be integers, and their greatest common factor has to be 1. So that's one that we know a fair bit about after covering 2.2. If you need to review it, go back and watch that video. Then we have slope-intercept form, which coming into this curriculum is probably the one that we knew the most about, y equals mx plus b, where m is the slope of the line and b is the y-intercept. And so it has that very appropriate name, slope-intercept form. And then finally, the last one, point-slope form, which is y minus y1 equals m times x minus x1. Where, again, m is still the slope. We're just going to reuse that name. And x1 comma y1 is any point on the line. It's a point on line. So any point that exists on this line can serve as our x1 and our y1, just the x and y coordinates from that point. So this kind of begs the question, why do we have so many different ways to write linear equations? And the reason is they're going to be really convenient for some situations, all of them. If we're given a point and the slope of a line, well then it's really easy to just write it in point slope form. It might be more difficult to just straight away write it in a different form. So we do want to kind of keep that in mind when we're attacking these problems. Which of our three forms that we're talking about will be the easiest to use to write our equation? So right here, converting between forms, y equals 3x minus 2. First question is, what form is this currently in the answer? Of course, we can see this y equals mx plus b. This is our slope-intercept form. And if you're worried about that plus b being a minus 2, remember we could write that as plus a negative 2. And so just because the sign is different doesn't mean it's not in the correct form. So our goal, and I didn't really spell this out on this piece of the notes, I want to convert this to standard form, and I want to convert it to point slope form. So which one will we go for first? I mean, either one actually isn't too bad in this case. I'll go to standard form first. So standard. We're starting with y equals mx plus b. And to get it in standard form, we know we need to get to ax plus by equals c. We need to get the x's and y's on the same side. X's should be positive, all those rules that we mentioned before. So I'm going to start doing that. I'm going to say, well, I'm going to get the x's and y's on the same side. So I'm going to subtract y on both sides. So we get 0 equals 3x minus y minus 2. X's and y's are on the same side. I'll go ahead and add the 2. That looks like that'll serve as my c value. 3x minus y equals 2. And then just to make it look like standard form, undoubtedly standard form, I'm going to put those x's and y's on the left. 3x minus y equals positive 2. We can always just flip those sides because in an equation, both sides are equal. And so if we wanted to rearrange them and put one on the left, one on the right, then that's fine. 3x minus y equals 2. X's are positive, they're all integers, there's nothing we can divide out of a, b, and c, so that looks like our standard form. So not too bad, just rearranging, dividing if we need to. What about We have slope-intercept. What about point-slope? How do we get our starting equation, which was in y equals mx plus b, I'll write the actual numbers, 3x minus 2, how do we get that into point-slope form? Well, if you think about this, we have the slope already. Slope equals 3. It's that y equals mx plus b. And then what is the y-intercept? Well, the y-intercept is -2. We could say that that is the point 0, -2, because that's where we hit the y-axis. And so really, and I'm going to write that in green just to show it came from that equation, we have the slope, we have a y-intercept. We can just write this straight out. Y minus y1 is equal to m times x minus x1. Just by taking the y-intercept, which is a point on the line, and the slope, we can just put this in point slope from slope-intercept directly. And that'll always work out. If you have slope-intercept, it's really easy to go to point slope if you know that trick, know that equation. Some of you might be saying, what about y plus 2? Can we write this as y plus 2? Answer is yes. Y minus a -2, y plus 2. Can we write this as just 3x? Yes. However, I don't really like to. I will tend to leave it more in this form that I have boxed, simply because when you look at that form that is boxed without the simplifying, it should jump out to you as point slope form. You should see that and say, yeah, that's definitely an equation in point slope form, as opposed to the very bottom one, y plus 2 equals 3x. It doesn't really look like point slope form unless you can say, okay, that was x minus 0 because the 0 didn't do anything, and that minus a -2. So just to make things obvious and jump out at us, I'm going to typically leave them a little unsimplified, if you will, with that y minus -2. So that's my reasoning behind that. So we've just seen we can go from slope-intercept form to standard and point slope forms. What if we start in a different form? What if we start with y plus 3 equals 1/3 times x minus 2? Well, this is starting in point slope form. We see our y minus y1, y minus a -3 equals m times x minus x1, 1/3 times x minus 2. So we need to put this in standard form, and we need to put this in slope-intercept form. Now, kind of the cool thing is we definitely already have the slope. M equals 1/3, right? Because that's the m value. So we don't have the y-intercept like laid out right in front of us. I might go to standard form first. Again, there's no wrong answer on these, but I might go to standard. So if I'm trying to convert to the other two forms, I might say, okay, I'm starting with y plus 3 equals 1/3 x minus 2. And so how do I get this to standard form? Well, I need to get x's and y's on the same side. I need to make sure that x's are positive. There's nothing I can divide out. They're all integers, all those rules. So I'm just going to start doing things that my math instincts have kind of been honed to do. I'm going to distribute that 1/3. So y plus 3 equals 1/3 x minus 2/3. Okay, I already know that I'm not allowed to have any fractions in this. In standard form, they all have to be integers. So maybe what I do right now is, because I have thirds, maybe I just multiply both sides of the equation by 3 to get rid of those fractions right away. So let's do that. Let's distribute those 3's. So we get 3y plus 9 is equal to 3 times 1/3 x is just 1x minus 3 times 2/3, the 3's cancel, minus 2. And now it looks a little bit nicer. Now I can start rearranging things, not have to worry about those fractions. I'm going to say, let's move the 3y over. So 9 equals x minus those 3y's minus 2. I'll add the 2 over, 11 equals x minus 3y. And then to cap it off, I mentioned this on the last one, I'm going to kind of just rearrange it and flip the equation, x minus 3y equals 11. There's nothing there that can be divided out. Greatest common factor of 1x, 3, and then 11 is 1. There's nothing that we can divide out. They're all integers. X's are positive. This is looking pretty good for us. So then how do we go to slope-intercept form? Well, we could go to slope-intercept form from either one of these other two forms. So slope-intercept, I'll demonstrate just going from the original. We start with y plus 3 equals 1/3 x minus 2. And when I'm thinking get in slope-intercept form, the biggest thing that I remind myself is that basically means get y by itself and then simplify everything else on the other side of the equation. So I'm going to say, okay, well, this is y plus 3 equals, let's distribute, 1/3 x minus 2/3. Okay, get y by itself. So y equals 1/3 x minus 2/3 minus that 3 that I just moved over. And here maybe is the trickiest part, which isn't too bad. I'm going to simplify those off to the side here. So negative 2/3 minus 3 over 1, because we can always put it over 1. Well, to add or subtract fractions, I know I need a common denominator, so I'm going to multiply this by 3 over 3. So that gets us negative 2/3 minus 9 over 3. And now we can combine them. Negative 2/3 minus 9/3 will give me negative 11/3. So sometimes I'll do this. I just like to do some of that work over off on the side. Y equals 1/3 x minus 11/3. And that way it's off to the side, doesn't really clutter things up too much. And yeah, and so we get our y equals mx plus b. I should have written that in a different color, I'm now realizing. Y equals 1/3 x minus 11/3. So just by getting y alone and simplifying everything else on the other side of the equation, we can go from point slope to slope-intercept. So we've seen slope-intercept to the other two forms. We've seen point slope to the other two forms, which means you can probably guess what's coming. What about if we start in standard form? ax plus by equals c, 4x plus 2y equals 11, and want to go to the other two forms. Now this one I do have a recommended way to go. I think it's easier to put this in slope-intercept first, so that's what I'm going to do. So slope-intercept. So we're starting with 4x plus 2y equals 11. If I want to go to slope-intercept form, my y equals mx plus b, just think back to the last example. Get y alone and simplify everything else on the other side. So I'm going to do that. I'm going to say that means 2y equals negative 4x's plus 11, subtracting that 4x's over, and then divide everything by 2 to get y by itself. Wrong color. Nope, right color. Y equals negative 2x's plus 11 halves. And so just by getting y alone, that gets us into slope-intercept form. Y equals mx plus b. Which, why I say I think that's easier to go to slope-intercept first and then transition into point slope is because we now know m. M equals negative 2. We now know a point. This is just like that very first example. We know that 0, 11 halves is a point on the line because that's the y-intercept, which means I can go straight to my point slope. Y minus y1 is equal to m x minus x1. And now we have the same equation written 3 different ways in our 3 different forms. So these last 3 examples have been just to show you, yeah, we can manipulate these equations and not change them, but just change the way they look to get whatever form we want. How is this useful? Well, picture a problem like this. Write an equation in slope-intercept form for the line that passes through the point 2, -5 and is perpendicular to this graph. Okay, so this is going to encompass a couple skills that we have from previous sections. I know I need to go through this point. And anytime I see that in a problem, I'm immediately suspicious that I'm going to use point slope form, at least at the start. I know it says get it in slope-intercept form at the very end, but we might go through point slope form because we saw if we can write something in point slope form, we can convert it really quickly. So what else do we know? We know that our line needs to be perpendicular to this graph. And if you remember back in 2.3 slope, we said that the perpendicular slope is the opposite reciprocal of our original slope. So our original slope here that we're given is 1/4 m original, the original slope. So what then is m, and I'll draw the perpendicular symbol. What is the perpendicular slope going to be? It's going to be the opposite, so change the sign, reciprocal, flip the fraction, and I'll just write that as -4. So I know a point, I know my slope. I'm just going to start this in point slope and then convert it over to slope intercept. So let's do that. So y minus, what was my y1? It looks like -5 from that point we were given, equals m, which is -4, times x minus x1, which is 2. And you're going to want to become really familiar with these equations. To get it into slope-intercept form, we just got to get y alone. We've done this. I'm going to let you just work this one out, get y alone, get it in slope-intercept form. So pause the video, and then when you're ready, unpause it, and you'll see my answer, and hopefully ours will match. So here I need to find my pause the recording button. Here we go. Go ahead, pause your video, work it out, and then hit play when you're ready. All right, as you can see from my screen, I've worked this one out, gotten this equation in slope-intercept form, y equals -4x plus 3, being really careful with the negatives, minus a -5, distributing the -4. I think that would probably be the most common place for a simple mistake. So hopefully you found some success with this one. If not, pause it and see how my work differs from yours. But we've seen all of these forms before, standard form, point slope form, slope-intercept form. Today was just about proving we can go back and forth in between them so that if we get a question like this, write an equation in slope-intercept form, but it's easier and more convenient to write it in point slope form at the start, we'll do that and then just convert it at the end. And we can absolutely do that, and it's not a big deal. So guys, this was section 2.4. You're gonna have some practice problems on this, but hopefully this was helpful. Rewind it. If you need to watch something again, write down a question if something doesn't make sense so we can talk about it next time we're meeting together. And until next time, I will see you then. Bye.